Hello all, thank you for being here and welcome to the webinar on Introduction to Vehicle Route Planning. And I hope you are as excited as I am for the session. So let's start today. So before I start, I would like to give a brief introduction about me. So I'm Pradeep and I'm currently working as a technical lead for the software development of the autonomous stack. And I'm responsible for the in the areas of the non-deterministic environments like construction sites, or if there are areas which the autonomous cars cannot drive, how to handle those scenarios. And the next one is to check if the driver is attentive in the car. You might have seen this news recently where a few of the drivers were falling asleep with the Tesla autopilot, and it's not good as of now because the cars are not so advanced. So that's one of my job, to prevent that from happening, to check if the driver is available and he's taking care of the car. And I have my master's in electronics and robotics, and I did my master thesis on vehicle route planning, and that is what we will be discussing today. So during the session, if you feel I'm too fast, too slow, and if you are unable to hear me properly, please write it in the chat or let the host know, and she'll be able to let me know that, and I can change accordingly. As this is a long session, please give the feedback in between. So if you are losing me somewhere, or if you need to revisit some topic. And so let's start with the today's session. So what we will be going through, this is the rough agenda for us today. So we will talk about the introduction to robotics or the autonomous driving, and then we look into the basic workings. What is the general ideology? What are the methods used? And how do we represent this trajectory planner? Then we look into the examples of the vehicle route planning. We have some demos planned for us. I'm not doing a demo, but you'll see some of the videos which explain the topics that we will be discussing now. And then we look into the evolution of the robotics or the autonomous vehicles over the time. And then we look into the career opportunities in the end. We can determine, okay, this topic is interesting. Is it worth studying for the future or not? So with no further ado, let's start with this big question. I think, why robotics? This has been recently a big debate in the media or in industry, because we have seen that the robotics are becoming robots are becoming more and more powerful currently, with the new techniques from artificial intelligence and also the advancements in the machine control, electronics, batteries. They can operate for much longer durations compared to previous times. And the robots have always promised to make the world a better place. But there are also a lot of people who are skeptical about this and who think that robots are a doom, that gonna change the humanity for the bad. So I think this Terminator versus Star Wars debate is always there, and depending on whom you ask, they have different opinions. Personally, I'm of the belief that it's a Star Wars ending, and the robots are gonna help us to form a better future for us and do things. We can look into some of the scenarios where we are currently using robots, and we can decide it for ourselves. And robots, let's say, I think the most common application for robots is in the industries, where they have made the industries more efficient, they have reduced the cost, they have increased the safety of the workers in the industries, and they can work tirelessly and handle repetitive jobs 24/7. So we know that robots are nowhere to be replaced, because it's impossible for certain scenarios to be done or taken care by humans. Some things like there are operations which are done at 200 to 300 times per second, which are not possible with humans. So for this handling strength and speed, robots are necessary and they are being used. And the next one is the safety. I think this is the most important things why we need robots. Think of a disaster like Fukushima nuclear reactor disaster, which happened a few years ago. And I think that the risks are so high that it's impossible for humans to go inside and clean up the site. They have been sending robots to clean up the site, and even those robots are unable to stand for more than few weeks or few months because of the high levels of radiation and damage to the circuitry. So in those environments, it's not safe for humans to operate, and we can leverage on the fact that we can send robots. Even if they're spoiled, it's okay, and we don't have any long-term effects on the humans. And also the robots are being used in mines and other hazardous places where where it's not safe for humans or to check for poisonous gases before the humans get inside the mines. So there are a wide range of applications. I think the most interesting things what we'll always see in the media about the robots is the space. So space has become a new frontier for the robotic exploration. Robots, before few years, it was always humans who were going to space and performing the experiments. and there were also some experiments which are done manually or automatically, but with the robots it has increased the scope a lot more. So all the Mars exploration, so robots have been on Mars before humans. I think that tells us how significant they are in changing the humanity's course in the future. So let's not wait too much further. Let's talk into how robots are working and what they are doing. So the first thing is the introduction of the architecture. What are the main topics in a robot, or the main components in a robot or an autonomous vehicle? So you have four components. One is the sensing, perception, planning, and control. Sensing is more like gathering the information with the sensors to see the objects with the cameras, or to detect things with the radars or other sensors. And the perception is to provide meaning to this information. Like if you saw a pedestrian, where is he? So something like that, and to make a sense of the environment around us. The next thing is planning. Planning is to plan the next actions, what to do with this information. And the last one is the control, which is the execution of these instructions. This is the overall thing, and this is a cyclic process which goes on and on. We will look more deeper into this one in the next slides. But for now, just remember that we have four components. One is sensing, perception, planning, and control. Let's go to the next slide. So this is the planning architecture. It's the similar information that we saw in the previous slide, but with a bit more information. So generally we have a car which is seeing the information through the sensors. So currently the cars are equipped with cameras, GPS, radars, lidars, ultrasonic sensors, and a lot more sensors inside the car to monitor the driver and to check the car's health. So all of this information needs to be fused together because there are different, let's say, there are different sensors, and each one is seeing different things. But to create one world view together, like for this car as an overall, what it is seeing, we fuse the information from different sensors. So that, let's say, like you fuse the information from eyes, from ears, and from touch to know that, okay, something is to the left, something is to the right. And all of this information is put together. So we have this sensor fusion. So now we have this world view. And the next one is the perception. Perception is assigning meaning to this. Let's say, so if I'm an autonomous car, what what is perception for me? I've seen a human which I received from the sensor fusion. Okay, there is a human. I want to know, okay, if the human is on the footpath or he is on a traffic light, so that I can plan my action accordingly. So assigning meaning to the objects around us is the perception. And this is a bit gray area, like what is perception, what is sensor fusion. It is really hard to differentiate. It's all part of perception. Some people call it together, some people differentiate it, but it's up to you what you feel most comfortable, or up to people who are explaining to you. So planning and perception and sensor fusion are sort of together. And the next one is the localization. I think this is also one of the most important things in the whole environment, is to understand where we are, like so where the car is with respect to the whole world, so that you can plan your next actions. And the last one is the prediction, is to understand what would be the behavior of the objects that you have seen in around. We have seen a human in front of us, so we should be able to detect, okay, is he gonna cross in front, or is he going away from the car, so that we can drive normally. If we predict that no, the human is gonna come in front of the car, we have to brake the vehicle. Or we see a car in front of us, we know that the car is gonna take a left, what we should do. If the car is gonna drive ahead, or if the car is gonna brake, we have to predict those actions and plan our actions accordingly. So this is with respect to the environment that we see, and this plays a vital role in planning. So when it comes to the planning, we have four layers or four submodules which are widely accepted. One is the route planning. Route planning is the overall top level route planning, something like Google Maps. And next we have the behavioral layer. And next we have the trajectory planner and the control module. We will go through each of this in the next slides. But for now, remember that we have four layers in the planning, and we will also touch upon the below topics that we have seen, like where they interact with each other in the next slides. And I hope it's clear till now, or I'm making some sense to you what you're seeing here. And the next things, so let's start with the first layer in the vehicle route planning. So the top layer is the route planner. we can say generally it's also called high level planner or high level route planner. This is more like the Google Maps, but a bit advanced version. So this gives you, like you say, okay, I'm here, I want to go from point X to point Y. So then how do we drive there? So with the Google Maps, we generally get multiple route options, and we also get the information like, okay, so there is no traffic area here, there is high amount of traffic, there is a blockade or something, and this is the best way to drive, something like this. So we receive this information, and this is the route planning. Generally for route planning, we need better maps. So we use HD maps. HD maps are the maps which also, along with the route information, they also have further information like where is the traffic sign, where are objects around, where are the lane markings, what are the different types of lane markings, like you have dashed lines, you have a continuous line, whether you can, and also information on if there is a bicycling path beside. So there is a lot more information, and also the static objects that are in the environment like footpaths, curbs, etc. So this information will also help in localization to understand where the car is. So think of this, maybe you would have experienced this situation where you're trying to find a friend at a busy street, and he's trying to explain you the directions, but it becomes very hard to find him or her because there is so many things around, and to differentiate what exactly he's mentioning or she is mentioning. So let's see from a car's point of view. So wish for the autonomous driving to be safe and efficient, we should have a localization of up to 1 to 5 centimeters difference. So we should be able to localize the whole vehicle to that much accuracy. And this is a huge challenge. And this is one of the widely researched areas in the current autonomous driving industry. So let's say how this information is helpful. So if we know that what are the landmarks around and everything that is surrounding, it becomes easier for the car to localize and also to plan like which lanes to take, which lanes not to take. So all of this information is in the high level route planner, and which exits to take. And these maps are updated in the real time so that we know, okay, about the traffic jams, if there is a construction going on in between, if a road is blocked suddenly, all of this information is needed for the route planner. So that is used in this layer. And so this in the let's say in a generic level, we can understand that this is like Google Maps showing you directions from one point to another point, but the maps that are used here are a bit more advanced, and they're called HD maps. You can look up for the HD maps if you're more interested in this in the next after the session. Let's go ahead. We go to the behavior layer. So this is the second layer in the vehicle route planning or the robot planning. And let's say like if we can take this small analogy to understand the behavioral planner better. If you have seen any time a rally racing, you would have two drivers in this car. One is the person who is driving, and the other one is a co-driver who is talking gibberish like MC1 100 KL2 100 KR2 200 SQL and so on. So what does it even mean? So it generally translates to something like this. I am the main control one. In 100 meters ahead, we have a nick left with a severity 2. And after that, in the 100 meters, we have a nick right with severity 2. And after that, in 200 meters, we have a square left. So this is the information that we are providing to the driver so that the driver is prepared for what's going to come up in the future so that he can drive and turn more efficiently. So his responsibility is small compared to looking for everything. So that is the behavior of co-driver is similar to the behavior of the behavioral planner or this layer in the vehicle. So what are its responsibilities? So it has to make a feasible, a safe, legal, and efficient decisions. So what is feasible decision? Like if it should say that, okay, don't, if there is a road ending, it should ask don't not to drive in that direction. Say take a left or right, and also don't drive on the bus lane or carpooling lanes, and also to check if it is safe, that if this area is safe, that if the road is not good, or if there is something bad happening there, or if there is a situation there, then it's not safe to drive, or if you observe humans there, it is not safe to drive autonomously, etc. So it is to decide, okay, this is safe to drive, it's okay. And the next one is legal requirements, like when to, in which direction to overtake, or to give way for the ambulance, or to say that, okay, you should always maintain this much distance to the car ahead. or to stop at a traffic light. So these are all the legal requirements and also efficient and also important things for driving autonomously on the streets so that it can blend in easily with the human drivers. So these are the responsibilities of the behavioral planner, and also to suggest, make efficient suggestions to the trajectory planner, like, okay, overtake this vehicle in front of you, then the route ahead is much more smoother. So something like this. And what are not the responsibilities of the behavioral layer? One is the execution. So it only suggests what to do, but it does not execute those suggestions. And next one is the collision avoidance. To avoid the obstacles or the other things on the road, it is the job of the trajectory planner, which we will look into the next layer. So how does this behavioral planner work generally? So this, in the current level 3 scenarios, mostly it is a rule-based system. So you have a lot of traffic rules. All of these traffic rules are combined into a state machine or something like that. And then this information is passed on to used to make the decisions. And these are not super efficient. And there has been a lot of research and also current research going on in the behavioral layer to see what is the best way to make it more modern and more for the urban areas where there are more uncertain situations, there are more turns, more traffic signs, there are more rules to follow, which cannot be packed into one thing. So for currently, for most of the highway pilots in the market that we will have, we are having a rule-based engine. And for the future, there is a lot more research going to use machine learning models and other things to create the models for the prediction of a better behavior for the autonomous vehicles. And let's go to the next thing, which is trajectory planner. This is the trajectory planner. This is the third layer in the planning and the very crucial layer. What are the responsibilities of this layer? The responsibilities of this layer is to create collision-free, kinematically feasible, efficient, and reactive trajectories. Let's say before we do this, let's answer this simple question. What is a trajectory? So a trajectory is a representation of space-time for the vehicle future. So like if you can see in the slide here, like you have the blue, that is the current position of the car. And let's say on the right lane, you see the car in gray. So that's like the position of the car in the future at 1 second, at 2 seconds, and at 3 seconds. This is what it is, trajectory is represented. So generally trajectory is represented in space. Like it should be at this point in this time and this point in this time. And then it is represented using polynomials or splines. We will look at in the next slides, but trajectory in general is the future representation of the vehicle. And what does collision free mean? So it should not collide with other things on the vehicle, on the road, like other cars or obstacles. It should be kinematically feasible because you have a lot of trajectories. Like the car, you know that the car cannot drive in any direction we want. So you can only make certain curves or something. So it should be feasible for the car to drive. Like I cannot say car, okay, go to 0 to 200 in 2 seconds. It's not possible. So it should be feasible. So we should create the trajectories with these restrictions, and they should also be efficient. And also reactive in the sense like if we are driving and we should be able to stop the vehicle if there is an obstacle. So our trajectory should not lead us to a dead end. So this is the whole goal for the trajectory planner. And people use different terminology, like there is trajectory planning or path planning. So, and in the robots terminology, it was always called path planning because the dynamic environments were not so much of a thing, and the velocity planning was done later because the robots are always stopping if there is something, and they don't need to plan a lot of things. So with the autonomous driving, the term trajectory planning makes more sense because it's a space-time planning, not just space planning. So we call this the trajectory planner, and we look a bit more about the trajectory planners in the next slides, where we understand how the planets work, what they do, and what is inside them. So before we go ahead, let's do a small recap on what we have learned. So we saw about the different layers and how they are interacting. So this slide tells you more about like what are the different planning layers or the different layers in the autonomous vehicle or the robots and how they interact with each other. And you see the little circles on the left side. This conveys a crucial information. So this is basically telling how fast each of the module is operating. So generally the motion control is the fastest module. So this is operating at around 100 Hertz. This is making decisions at every 10 milliseconds or even sometimes 1 millisecond, because the control has to be very precise. It should not it should be very comfortable. So if you get into an autonomous car, you should not feel that you're thrown away everywhere. The drive should be very smooth and so on. So this is the motion control which is responsible for that, and this is doing this job and it's operating at a very high frequency. And we have sensor fusion, which is operating at a slightly less frequency. We have localization and trajectory planning, which are operating generally at 25 Hertz. And next we have prediction and behavior layer. So behavior layer is operating between 1 to 5 Hertz, and the decisions that it is making are valid for the next 10 seconds or so on. And we have the route planner on the top, which generally is planned once and it's valid for the whole route unless something really bad happens or there has to be a wrong turn or the road blockades, but this is valid for a much longer time. So this is the whole interaction between the different planning modules. And let's look next more into the trajectory planner and what is the responsibility and how does it work. We have planning. So the planning in general is divided into two areas. One is the unstructured environments, other is the structured environments. So what are unstructured environments? They are like something like parking lots, or if you have a blockade on road and there are no definite route markings to drive, or there is a construction site and then there is a lot of things going on and we don't know what where is the differentiation between the road, or we have to drive outside a bit, etc. And then we have structured environments like highways or inner city roads, which are planned. So this is generally the differentiation on top level, because the algorithms that you apply will be based on this, like where you are driving. And the next thing, we look more into the trajectory planning. This